We're on chapter 10B, and my intention is always to go quickly through these, but the videos seem to take a long time. So let's see how fast we can go. I'm going to start with two examples before we get to the problems of how to do proofs with similar triangles. You might like these. These might be where you start understanding proofs. So let's start. This problem says segment CB is perpendicular to BA. So CB, BA, so they form a right angle. I'm just putting in all the stuff that we have to prove first. CD is perpendicular to DE, all the givens, I mean. Now, to prove that two triangles are similar, it's actually easier than proving that two triangles are congruent. To prove that two triangles are similar, all you have to do is prove that two angles are the same in each triangle, and then you'll have the triangles are similar. So let's see if we can do that. I think you're going to like this. Let's give it a try. Okay, so we're going to prove that these two triangles are similar, we have to get two angles the same. Well, if we know that this angle is, if this segment is perpendicular to this segment, then we know that angle B is a right angle. And we know that angle D is a right angle because we know that perpendicular lines form right angles. We also know, one of our favorites is that this angle is congruent to this angle. So we have these congruent and we have those congruent. How are they congruent? Well, we have to say them first. We have to say angle ABC is congruent to, so we have ABC, angle EDC, and that is, anybody? It's vertical angles are congruent. All right, so now we can say, since we have two angles in this triangle congruent to two angles in this triangle, we can actually say right away, triangle ABC is similar to triangle EDC. And that is because the theorem, you can just say on this one, hold on a second, I want to make sure I get this right. We would say the angle-angle theorem. And that's it, angle-angle theorem. Because if two triangles are similar, all of their angles are going to be congruent. Their sides are going to be proportional. But if two of the angles in a triangle are congruent to two in another triangle, then the third angle is automatically going to be congruent. So here we have it. To prove two triangles are congruent, you just have to prove that two angles in one triangle are congruent to two angles in another triangle, and that's your angle-angle theorem. All right, they do get a little bit harder, so let's scroll down here. I'm having a little scrolling problem like yesterday, I guess. My scroller's not working. How about that? Okay, there we go. Okay, this one says AB is parallel to DE. We have to prove that the sides are proportional. So we're going to prove that EC is proportional to BC and that AED, I don't think that's supposed to be ED. It's supposed to be EDAB. EDAB, yeah, it is. And then this side is proportional to this side. So basically what we want to do is prove that the two triangles, so we're going to have the triangle, this triangle right here, we're going to prove that it is similar to this triangle out here. Now the way that we prove these two triangles are similar is we have to have two angles in one triangle congruent to two angles in another triangle. So let's see if we can do that. Now we're given that they're parallel. So if two lines are parallel, these two lines are parallel, then we know that this angle is congruent to this angle. So we would say angle, you have to label them with, you could say angle B is congruent to angle CED, and we could say that angle DA down here is congruent to angle EDC, and that's called corresponding angles are congruent. Once we get there, then we can say that the two triangles are congruent. Since this angle is congruent to this angle and this angle is congruent to this angle, we can say that the green triangle is congruent to the purple triangle. So we can say triangle ECD is congruent to, or similar, not congruent, they're similar if you get two angles congruent, is similar to triangle BCA. And that again is our angle-angle theorem. And then if the triangles are similar, then their sides are all going to be proportional. There we go. And that reason would be corresponding sides of similar triangles are proportional. Now we're going to use all this to do the problems that we didn't finish yet. So let's go with 9. And I don't have my number 9 paper with me, so I might have to run and get it. It has all the calculations done on it, but let's just start on it. So these take a little bit of time, unfortunately. Maybe we won't do them all. All right, let me just draw the triangle. I wanted to squeeze some of those proofs in. I have some more at the end too. So here we go. Draw this triangle. Wish there's a faster way to do this, but there's not, so you're going to have to bear with me. I'm kind of whispering because Savannah, you know Savannah, our friend, she's sleeping in the other room. KWH. All right, here we go. It's telling us that KW is parallel to EG. And they want us to find the length of each indicated segment. So I'm just going to fill it in each time, I think. HE is 20. And KE is 12. And then we have WG is 9. And we need to find HG, which is the longer side. I think you're going to find these actually to be pretty easy. Now, if they're parallel, what that means when they're telling us it's parallel, we know that the corresponding angles are all going to be congruent, right? So basically we're saying that the little triangle is similar to the big triangle. So all their parts are going to be proportional. Now we can fill them in a little bit. We know that this one's 8 and that we know this one is going to be, we don't know this guy either right here because we don't know what x is. But we can set up our proportions. So we can say 12 is to 20. Well, actually we can't do that one. We have to say the little triangle is proportional to the big triangle. So we have to do the little triangle to the, actually we're not going to do it that way because we don't know the little triangle's top on that one. So we're going to have to say 12 is to 20 as 9 is to x. And so we're going to cross multiply. And I don't have my paper with my calculations, so I'm going to multiply them out now. 9 times 20 is 180. You divide by 12, and you're going to get 15. And guess what? I hear a baby crying. So hold on a minute. So yeah, we get 15. So all these, I think you can do number 9s. Just draw your picture. If you don't have, you might have to fill in some numbers to be able to do the problems. Just make sure you do, like I did the bottom part to the side, the bottom part to the side. So just make sure you keep it in order. Let's just do, we'll do one more. Let's do C, just see what happens. I'm just going to write the numbers in a different color so I don't have to redraw it. So let's do C. We'll do C in green. HW is 4. So this one's 4. And we have WG is 12. WG, this time is 12. And we have HE is 28. All right, we have all kinds of different sides here. HE is 28. We have to find KH. KH is the one we have to find. So hopefully it's not too confusing with all these scribbles outs. All right, so this one here is 28. Doesn't seem like we have enough parts. Let me just check and make sure I did everything right here. HW. I put that in the wrong spot. HW is 4. There we go. Now we have enough parts. Sorry, this is so messy. HW is 4. Okay, now we have enough parts to do it because we know that this long side is going to be 16. So here we go. So we can do, we have this part. I can't even read my writing. KH is what we're trying to find. So we can do big part, which would be, let's do little part. Let's do 4 to 16 equals what we don't know, question mark, to 28. So if we're going to do the top on this side, we have to do the top on this side. The long side on this one, long side on this one. So we're just going to cross multiply. 4 times 28 is 112 equals 16x. We're going to divide by 16 and we get x equals 7. And that's all we have to do for that one. Just check that. Okay, let's move on. Let's go to number 10. All right, they start out pretty easy here. We're doing all kinds of different things. So we have triangle gal. Let's do 2 triangles. We can just use my little triangle maker. Here's a triangle and a triangle. So we're given that these are similar triangles. That similar triangles means that their sides are proportional and all their angles are the same, but they're not congruent. S-H-E. So they want gal and she. That's pretty funny. They want to name 3 pairs of congruent angles and 3 equal ratios. So if 2 triangles are similar, that means that angle G is going to be congruent to angle S. Angle A is going to be congruent to angle H. Angle L is going to be congruent to angle E. All the angles, when they're similar, are congruent. Then the sides are going to be proportional. So GA is going to be proportional to SH. You want to go in the same order, GA, SH. Now we'll go AL. HL is going to be proportional. Whoops, where did I get HL? AL is going to be proportional to HE, and all these proportions are going to be equal. And then LG, so L to G, is going to be proportional to ES. And those are your 6 different things that they wanted you to write. 3 pairs of congruent angles, 3 equal ratios. Okay, let's talk about altitudes. I think you're going to find this easy too. Altitudes of similar triangles are also proportional. So 11, it says the ratio of similitude, which just means the proportionality of the sides, is 3 to 5 of 2 smaller polygons. So let's just draw a polygon. Polygons could be anything. It could be just a rectangle. So there's a polygon and there's a polygon. I can't draw any other shapes. Okay, we know they're similar because they have all right angles. So if they're similar polygons, all the angles are going to be the same. And it's just telling us that the ratio of 2 similar polygons is 3 to 5. That means this side's going to be, since this is smaller, this is going to be the 3 and this is going to be the 5. If the length of the shortest side of the smaller polygon is 24, find the shortest side of the longest polygon. Well, if this is, the ratio is 5 to 3 here, so the ratio is going to be 5 to 3. We can just do it like that. And the smaller side is 24. It has to go with the 3. And then we have to find the larger side. So they're giving us the ratio of proportionality. So the shorter side is 24, so it has to go with a smaller number. So we're just going to cross multiply. 5 times 24 is 120 equals 3x, and we're just going to get 40. So the smaller side is going to be 40. And that's all there is to that. All right, keep going here. We're out of room on that board. Let's move on. 12. This time we have two triangles. 1, 2, and they're similar. So we make this similar sign. It says ZAP, Z-A-P, is similar to MYX. ZA is 3. AP is 12. ZP is 21. YX is 20. That's all they give us. Find the remaining sides. Well, if the triangles are similar, then their sides are all going to be proportioned. So we have this side and we have this side, so we can make a proportion out of it. 12, they call that the similitude, the ratio of similitude. That's a kind of cool name. So what I like to do is I always like to reduce them before I start. So 4 goes into this 3 times, it goes into 25 times. So come up with your ratio, reduced ratio of similitude, which is this one. Now I'm going to just label these some letters here. We'll just call this little x and little y. So to find x, now the bigger number is the 20, goes on the bottom. So x needs to go on the bottom. It needs to stick with the bigger triangle. Mine are backwards actually, because this triangle here is obviously bigger. All right, and then we're going to go with the 3 on that triangle. So the ratio here would be 3 to 5. So this isn't going to be it. The ratio is just going to be 3 to 5. So the 3 needs to stay with the 12, and the x needs to stay with the 20. So we cross multiply. So we get 3x equals 15, and we're going to get our first side is going to be 5. All right, let's do the next one. We use the same ratio. Let me just, actually I'm going to keep it 3 to 5. Now we need to find y. Y is with the 20, so it has to go on the bottom where the 20 was. And this time we're going to use this, I can't read my number there, 21. So we're going to put the 21 up here. These two go together. They're on the same side of the triangle, the bottom. So they're the ones that are proportional. So we cross multiply, we get 3y equals 21 times 5, it's 105. Divide by 3 and we get 35, so y equals 35. I'll try to get my triangles straight, right one, with the bigger one going with the bigger triangle next time. Okay, 13. 13, quadrilateral, ABCD, is similar to RST. All right, I'm just going to have to do these two. We've got the quadrilateral and the quadrilateral. They're similar because the angles are all the same. That means all their sides are going to be proportional. So let's see, we have ABCD, ABCD, and RSTW, RSTW. The lengths of ABCD are 3, 6, 9, and 15. So I'm just going to go, obviously it's not this kind of quadrilateral, but we're going with it. 3, 6, 9, and 15. And the lengths of the longest side in RSTW is 20. Well, the longest side on this one is 15, so we have to make sure it's in the same place on this one, so they match up. Now we have 1 in this one and 1 on this one, so we know the sides are proportional because the quadrilaterals are similar. So we can say 15 over 20. I'm going to reduce it just to make our numbers easier. You don't have to. So I'm going to make it take 5 into both of those, so it's going to be 3 over 4. So now we're going to find the other parts. So we can call this one x, y, and z. So we're going to find the other parts. The 15 is on the top, so this 3 has to go on the top with the x on the bottom because the 20 is in this quadrilateral and the 20 and the x have to line up. So we're going to cross multiply. We're going to get 3x equals 12 and we're going to get x equals 4. Okay, let's get y. So here's y. So we use our 3 over 4, which started out as 15 over 20. So let's just keep that in mind. Okay, which one goes with the 15? This quadrilateral, so we're going to use the 6 over the y, because here's our 20, and we have to make sure these two sides are the same place. We cross multiply 3y equals 64, divide by 3, and we get, whoops, did I cross multiply wrong here? 16 times 4 is 64. Divide by 3 is something I did wrong. Okay, hold on one sec. You're probably all seeing it, but 15, 3, 4, 6. This should have been a 6. I don't know where I got a 16. Hold on a sec. Let's do this again. 3 over 4. Okay, and so we're going to have the 6. I don't know where I got a 16 over y. So we get 3y equals 24, y equals 8. And we have one more side to do. We have our 15 over 20. It reduces to 3 over 4. And we have to get our z. The z goes with the 20. So z goes down here, and the 9 goes here. Cross multiply, 3z equals 36. Z equals 12. All right, these are pretty simple. I think we did these like in Algebra 2 somewhere along the way. Okay, let's see if we can do one more on this page. All right, so we are on 14. We're almost there, actually. The longest side of the polygon exceeds twice the length of the longest side of a similar polygon. So by 3. Find the ratio of similitude of 4 to 9. Find the length of the longest side of each polygon. Okay, so let's just do our rectangles again. All right, and let's just make the bigger one this side this time. Okay, we have the longest side of a polygon exceeds the longest side of a similar polygon by 3. So let's just make, actually I'm going to get rid of these and do this right. Let's do these things. Let's do trapezoids because it actually has a longest side. So we got that longest, we have that trapezoid, and let's draw another one. So we got that. Let's just draw a bigger one. They're not going to be quite similar, but you get the idea. All right, here we go. All right, it says here that the longest side of a polygon exceeds twice the length of the longest side of a similar polygon by 3. So if this one is x, this one is going to be 2x plus 3. So it exceeds the longest side by 2 times the side plus 3. The ratio of the similitude of the polygons is 4 to 9. So we're going to use a ratio of 4 to 9. Obviously this is going to be the smaller one. Smaller, and this is going to be the larger. So it's going to be x over 2x plus 3. We're going to cross multiply. 4 times 2x plus 3 equals 9x. 8x plus 12 equals 9x. 12 equals x. So they want us to know, you have to answer the question, if the ratio is 4 to 9, find the lengths of the longest side of each polygon. All right, we have this one equals 12, and then this one's going to be 2 times 12 is 24 plus 3 is 27. So that would be that one. All right, 15 has a lot of parts. Let's see if we can go fast on that. Let's do a new whiteboard or blackboard. All right, 15, we are given triangles. RST is similar to, here's the bigger one. So we might have to redraw these for different problems. So RST and JKL. They are similar. It says RA and JB are medians to the sides. RA. So if they're medians, it means it's going to divide the opposite sides directly in half. Okay, they are medians. Now the thing to keep in mind here is that medians are also proportional. If the triangles are similar, the medians are also proportional. So this really isn't hard at all. So we have RS is 10, JK is 15, JB exceeds the length of RA by 4, JB, where's JB? I didn't put that here. JB exceeds the length of RA by 4. So if this is x, this is going to be x plus 4. Find the lengths of the medians, JB and RA. All right, so we're just going to do a proportion. So we're going to go left to right. 10 over 15 equals x over x plus 4. So 10 over 15 equals x over x plus 4. I always reduce them. You don't have to. 2 over 3 equals x over x plus 4. Cross multiply, so you get 2x plus 8 equals 3x. And you're going to get 8 equals x. So on this one, they want you to know the lengths of the medians. So the first one is 8. The next one is, this median right here would be 12. And that's it. Quickly now, because this is getting long. So we have the same triangles. Let's just draw the same triangles real quick. We got him and we got him. They are similar. We have, this time, let's see, RST, and we have JKL. KH and SH, so that would be this, they're altitudes now. So I didn't draw my little writing tool, did I? Whoa, that was really bad. Back to this. Okay, this time they're altitudes. It's the same as medians with the proportionality. So altitudes are perpendicular to the opposite sides, but they don't necessarily divide the side that they hit in half like a median does. And a median is not necessarily perpendicular. So here we go. SH is 12. This must be H is 12. And we're given that KO is 15. And we have LK is 3x minus 2. And we're also given that TS is 2x plus 1. So you just make yourself ratios. 12 is to 15 as 2x plus 1 is to 3x minus 2. So 3 goes into that 4 times, 3 goes into that 5 times. And we're just going to cross multiply here and get our answers. So we're going to get, let's see, 4 over 5. So we're going to get 12x minus 8 equals 10x plus 5. You're going to get 2x equals 13, and you get x actually equals 13 over 2, which isn't nice, but how it is. So that's not even an answer. They want to know the sides. So you're going to have to plug the sides into these two things. So if you plug it in here, you're going to get it equals 14, and if you plug it in here, you're going to get 17.5. Just moving on a little faster. Okay, C is the same thing. Perimeters are also proportional. So let's just see if I can slide down here. This is C. They're the same triangles. Same idea, same triangles. They're similar. We have RST. RST is similar to JKL. And we have the perimeters of the first one is 25. The perimeter of the second one is 40. I have them drawn backwards. Is 40. ST is 3x plus 1. And we're given that KL is 4x plus 4. I think you can do these. You just set the perimeters, make them proportional. 25 over 40 equals 3x plus 1 over 4x plus 4. You guys can figure that one out by yourself. Just cross multiply. If you can reduce first, that's great. All right, last one. And then I'm going to tell you what I want you to do with the proofs. We'll go over the proofs in class. The ratio of similitude is 3 to x. So let's draw these real quick and one more time. So here we go. I didn't really want it down there. Let's get rid of that and start over. All right, here we go. 1, and let's just put him up there. So we have our RST, RST, and our JKL. They're similar. It says the ratio of similitude is 3 to x, so that just means 3 to x. We don't know which one is bigger right now. SU is x minus 4. SU is the altitude. So SU, it's this guy. Altitude means it's going to form a right angle with the opposite side, but it doesn't necessarily divide it into 2 equal parts. The median divides it into 2 equal parts, but is not necessarily perpendicular. So these are perpendicular. SU is x minus 4. And this other guy over here is 15. Huh. They just tell us right on out what that guy is. All right, so you set a proportion. If this is the 3 to x guy, if the 3 one is on the left, we're going to put 3 over x, which means we're going to put x minus 4 over 15. You're just going to cross multiply and solve it. Oh, this one's a little bit different, so let me see. Maybe I'll solve this one for you. Hang on one sec. Let's make sure everything's set up. Okay, we're going to cross multiply, so we're going to get 45 equals x squared minus 4x. It's quadratic, so you have to set it equal to 0, like this. You're going to factor x minus 9, x plus 5. And then you're going to get 2 answers, x equals 9 and negative 5. Now you can't have a negative length, so you cross it out. So x would equal 9. You have to answer the question, find the length of SU. So it would be 9 minus 4, so SU would be 5. All right, I'm going to stop for now. Instead of doing problem 16 for your proof, I want you to try 17, 19, and 21. See if you can get those. We're going to go over all 3 of those in class, but you need to try them. 17, 19, and 21. All right, that's it for this video, and we'll see you on Friday. If I can stop the video, that is.
Did you cry when you woke up?
Yeah.
You did? No, I didn't hear.
That's because you're upstairs, maybe that's why.
I just came down. She was sitting up.
Hi, Chubby Bumpkin. Did you get some food?
She's drooling.